highest common factor. As the name suggests, you find the factors, look at the common factors and look at the highest among the common factors. So the largest number that divides the two or more given numbers is known as the highest common factor. It's the highest common number that can divide both the numbers simultaneously. To find the HCF of the given numbers, perform the prime factorization of all the numbers and then check for common factor. Once you understood the common factors, look at the highest common factor. Let's look at the numbers 72, 288 and 1080. I have to find the HCF of these numbers. So 72 can be written as 2 cube into 3 square. 288, the prime factorization form is 2 raised to power 5 and 3 square. 1080, the prime factorization form is 2 cube, 3 cube and 5. So I will look at the common factors and I will look at the highest common factors. So 2 is coming out to be 3 times in minimum all of them. What about 3? 3 square, 3 square, 3 cube. So the common factor that will be highest would be 3 square, which will give me an answer which is 72. HCF is given by the lowest indices of the common prime factor. Lowest, why? Because it has to be common in all the three. So whatever is the minimum would be the common. HCF is also known as GCD, greatest common divisor. Let's look at LCM now. LCM, as the name suggests, is the lowest common multiple. Multiple of a number is greater than that given numbers. So LCM of two or more numbers is the lowest number which is divisible by all the given numbers. So with all the given numbers, I find out a number which is divisible by each one of which is divisible by each of the numbers given. So after performing the prime factorization of the numbers, we find out the highest index among the given of all the prime factors. In case of HCF, we look at the lowest index, and in case of LCM, we look at the highest index that is there for all the prime factors. So the LCM is the product of all of these prime numbers with their respective highest indices, whereas the HCF was the product of these prime numbers with their lowest indices. So LCM of 72, 288 and 1080 would be, it's the same example that we have done. So 72 would be written as 2 cube into 3 square, 288 would be written as 2 raised to power 5 into 3 square, 1080 would be written as 2 cube into 3 cube into 5. Now if I have to look at the LCM, I would look at this 2 and the highest power, which is 5. I would look at this 3 and the highest power, which is 3. I would look at 5. 5 is only there once, so I will take it 1. So it will be 2 raised to power 5 into 3 cube into 5, which will be 4320. Now 4320 is the smallest number which is divisible by 72 and 288 and 1080. The next such number would be double of this, which will be 8640. That will be the second number which is divisible by all three of them simultaneously. Okay, so let's take two numbers A and B. LCM of A and B into HCF of A and B would be equal to the product of the two numbers. So this is valid for two numbers only. For two numbers, the product of LCM and HCF is equal to the product of the two numbers that you have. So example, let's A is equal to 120. I've done a prime factorization for this. B is equal to 18. I've again done a prime factorization for this. So LCM, I will take 2 cube, I will take 3 square and I'll take 5. HCF would be 2 and 3. 2 into 3, which will be 6. Now if I look at it, the product of LCM and HCF in this case is coming out to be equal to the product of the two numbers. This is a very, very important relationship that we have when we are talking about this thing. Now an important thing that you have to keep in your mind is it is applicable for two numbers only, not for three or more numbers. Another thing that you need to look at, if you know HCF, both the numbers will always be the multiples of HCF. So this will be some multiple of HCF, this will be another multiple of HCF, and LCM is also a multiple of HCF. Both the numbers and LCM are always the multiples of HCF. Look at some of the properties of HCF and LCM. The HCF of two or more numbers is smaller than or equal to the smallest of those numbers. So whatever is the smallest of the two numbers, the HCF would be smaller than or equal to that. Whereas the LCM of the two numbers is greater than or equal to the largest of the two numbers. So whatever are the largest of the two numbers, that will give me the minimum value of LCM. Whatever is the smaller of the two numbers, that will give me the maximum value of HCF. If HCF of numbers n1 and n2 is k, then n1 and n2 are always multiples of k. So both the numbers are multiples of their HCF. Since HCF divides all the numbers, both the numbers are multiples of HCF. That is what you need to understand. If HCF of two numbers n1 and n2 is k, then if I add up the numbers or if I subtract the numbers, still they are divisible by k. If the HCF of two numbers is k, that means the first number would be k times x and the second number would be k times y. This will be kx plus ky. You can take common, this will be x plus y. Again here you take common, this will be x minus y. So even if you add both the numbers or subtract both the numbers, they are still divisible by k. If L is the LCM of four numbers n1, n2, n3, n4, then all the multiples of L is the smallest number, all the multiples of L would also be divisible by n1, n2, n3 and n4. If a number n always leaves a remainder of r when divided by numbers p1, p2, p3. So what is there? If n is divided by p1, the remainder is r. If n is divided by p2, the remainder is r. If n is divided by p3, the remainder is r. Then the smallest value of such n would be given by LCM of p1, p2, p3. Now LCM would give me the smallest number which is divisible by p1 and p2 and p3. That means it gives a remainder of 0. Now what is the remainder that I want? Certain r. To this I add r. So it will be LCM or a multiple, because I am looking at the second highest number or the third number that is giving me such things. So it will be LCM of the divisors, which will be p1, p2, p3 plus a common remainder. This number would give me a remainder of 0 and added to a common remainder would give me my answer. Now in order to find LCM of fractions, I will divide it into numerators and denominators. If I club the numerators and find out their LCM and write it in the numerator, I'll club all the denominators, find out their HCF and write it in the denominator. That will be the LCM of fractions. So for example, let's look at 3 by 7, 6 by 7 and I have 5 by 4. If I have to find their LCM, LCM would be given by LCM of numerators. What are the numerators? 3, 6 and 5. And HCF of denominators. What is the denominator that you have? 7, 7 and 4. So if you look at the LCM, 3 and 6, the LCM is 6, 6 and 5, nothing in common. So the LCM would be 30. 7, 7 and 4, 7 and 4, nothing common. So the LCM of these fractions comes out to be 30. It is LCM of numerators divided by HCF of denominators. Similarly, if you have to find out HCF of fractions, it will be HCF of numerators and LCM of denominators. So if I just look back and take the same values, you're looking 3 by 7, 6 by 7 and 5 by 4. Now what I have to do is I have to find their HCF. It is HCF of the numerators. What is it? 3, 6 and 5 followed by LCM of denominators, which is 7, 7 and 4. So 3 and 6 have 3 in common, 6 and 5 have nothing in common. My HCF would be 1 divided by my LCM, which is 28. So this will be the answer for H. We hope you've enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam-related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.